In this video, we will introduce the basic concepts of probability theory. It was first discovered in the early 1600s by mathematicians who wanted to improve their chances in winning at gambling games. Since that era, probability theory has advanced to a wide spectrum of fields and professions. Currently, it's used by actuaries to establish the financial impact of uncertainty and manage risk. It is used to analyze and study the effects of decision making in areas such as finance, economics, and other academic areas. And it's studied in genetics and quantum theory. We'll look at some basic examples involving probability theory. First of all, one basic rule we have to be aware of is that each probability we compute is bounded between two values. It cannot be lower than 0 or higher than 1. So the boundary on the left side is 0, the boundary on the right side is 1, meaning that every probability we compute has to fall within these two values. Let's look at an example involving two dice. If two dice are tossed, find the probability of getting an even number and a sum greater than 8. Let's correct this a bit. Let's put an even sum and a sum greater than 8. Now, in order to work out this problem, I provided you with a copy of the sample space for two dice. This is posted in the module. Okay, so how we would work this sample space, let me just select the appropriate size, is that we count the total number of pairs. That is a total number of possibilities. So the pairs are the white and blue dice. There's 36 in total. That's going to be our denominator in the probability we're computing. Now let's go back to the question. It's saying an even sum and a sum greater than 8. When we see the word "and," you're thinking of all the outcomes that have both of these properties. So greater than 8 informs us that it has to be the sums 9, 10, 11, and 12. But with the stipulation of "and even," that means we only focus on those sums that are even. This includes the sum 10, in which there's 1, 2, 3 possibilities, and the sum 12, in which there's 1. So we will add those outcomes together. 3 plus 1 is 4 out of 36. And we should always reduce our fractions. So let me show you how this is done on a typical scientific calculator. On a calculator, you should have a fraction button, either n over d or some form of UND. It may be A, B, C. So let's type in 4. We select our fraction button, type in 36. And if we want to reduce this fraction, we simply select enter, and it's equal to 1/9. And that's our answer. Now, in the sample space that I provided, it is posted in the module just to remind ourselves. We also have a sample space of a deck of 52 cards. So let's answer this question: a jack or a spade? Well, how many jacks do we have? We have 4 jacks. 1, 2, 3, 4. So 4 out of 52. Plus, how many spades do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And the reason we add these probabilities is because the or informs us to add. When you see the word or, you're adding. But we have to avoid double counting the Jack of Spades. Right? If you notice, we counted the 13 spades, which included the Jack of Spades, and the 4 jacks, which included the Jack of Spades. So we have to ensure that we subtract out 1 Jack of Spades. Or you can do this mentally. It depends on how you want to perform the computation. So now we add 4 plus 13 is 17, minus 1 is 16 out of 52. And we can reduce that value using our calculator. 16 out of 52, enter. That reduces to 4 out of 13. And there's the video. So if you have any questions, please contact me involving probability theory. Thank you for watching the video.